Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today, we are going to start wrapping some major concepts up. We have been talking about this illustrious quadratic equation for some time now. And we've learned some things about it, but today we're going to really start finalizing and start getting close to really being masters of quadratic equations. Just little reminders that you should have in the back of your head. Quadratic means that the leading degree is 2. It's x squared. So that means you're going to have a quadratic function. That means you're going to have a parabola. The parabola is either going to be pointing up or pointing down. The points through which the parabola go through, those are my solutions. They're also known as the x-intercepts, the x value and y is 0. They're also known as your roots, and they're also known as your zeros. It doesn't matter if the parabola is pointing upwards or downwards. The x-intercepts are the solutions, also known as roots, also known as zeros, also known as x-intercepts. That rings a bell to everybody, right? For sure, right, guys? That's not like out of left field here. Okay, perfect. So there are several ways, my friends, to solve quadratic equation or function, such as y equals ax squared plus bx plus c. Remember, a is just a coefficient of x squared. B is the coefficient of x. C is a constant. It's a number by itself with no variable. What are the methods of graphing this? Now, remember, please, sorry, I also put or f of x. Please remember that f of x is just a fancy way of writing the y. F of x is the y. F of x is the output. F of x is the dependent variable. Remember that all f of x means is, hey, reader, this is function f where x is independent. Makes sense, right? You promise? I can't go further if that doesn't make 100% sense. Okay, cool. Now, there are 5 ways to solve these. Square root method, we're going to learn today. Completing the square, we're going to learn today. Using a quadratic formula, we're going to learn that tomorrow. Factoring, we've already done. You guys know how to factor, don't you? We know how to factor difference of squares, trinomials where the leading coefficient is 1, trinomials where the leading coefficient is greater than 1. That's when we use the Cuban method, right? Perfect squares. Okay, we got that. And then last but not least, graphing. And graphing we will be doing in a couple days. Okay? So these are the 5 ways to solve a quadratic function. When you solve a quadratic function, you are looking for the x-intercepts. That means you are setting y equal to 0 and you're solving for x. So when you solve a quadratic function, you're setting y equal to 0 and you're solving for x. Pretty simple, right? Remember, those x-intercepts are called solutions, roots, or zeros. Before, you would have been introduced to these as real zeros. Well, we have real zeros, and we can also have complex zeros. Because now we learned that if I have an answer that's square root of -4, that's plus or minus 2i. Right? We know about complex numbers now. So, does this make sense so far, what we got? All right, cool. Excuse me. Okay, guys, let's first talk about the square root method. Simple, simple, simple. In order to solve quadratic functions or equations using the square root method, the function must be in the form of y equals ax squared plus c. Notice that there is no bx value. because in this case, b is 0. 0 times x is 0. So when you have a function where you just have a squared value and a constant, you can use the square root method, okay? When the function is in the above form, simply set y equal to 0. Again, why? Because we're solving for the x-intercept.
The volleyball team for their game. Thank you.
Now, sorry about that, that threw me for a loop. When the function is in the above form, simply set y equal to 0, because we're finding the x-intercepts, and solve for x. Your solutions are the x-intercepts, the real zeros. They could be complex as well, so I should have just put zeros straight up, just zeros, or the roots of the function. So let's do this. We're setting y equal to 0 because I want to find my x-intercept. I have a squared x, I have a constant, I've got no bx value. Let's solve this. It is easy. Add 64 to both sides. X squared equals 64. What happened to the y? I made it 0. Take the square root of both sides. X equals plus or minus 8. So that means, I'm going to show you later how to graph this and how to sketch this. You will know all of what I'm doing in a couple days. But basically that means this. I have a parabola that went through positive 8 and negative 8. Does that concept make sense here? What is it that I'm solving for, dude? Excuse me. That's what I'm solving for. Sir. Did I just say, you don't know how I just graphed this, but you will learn that in a few days. The reason that it's a U and not upside down U is because the leading coefficient of x is positive. If it's positive, it goes up. If it's negative, it goes down. But I said I will teach it in a couple days, and as a man of my word, I will teach it in a couple of days. Thank you. Now, add 27 to both sides. Because again, I made y 0 equals 3x squared, divide by 3. 9 equals x squared, square root both sides. X equals plus or minus 3. Don't ask me how I knew if it was going up or down, but basically what's happening here is it's going through the negative 3 and 3. That is not the correct graph, by the way. That is just an estimate for me to show you what's going on. This is what you found, the x-intercepts. Does that make sense? I won't draw them again. I just want to make sure that this is driving home, that you understand what you're doing with this. Yeah, right? Easy? Cool. Next. Uh-oh. Oh, my God. How do I do this? This is x minus 2 to the second power. What do I do, guys? Square roots of both sides. Thank you, because we learned this just a couple days ago, didn't we? We know how to get rid of a power of 2. Square root cancels out a power of 2. I got x minus 2 equals? No. Plus or minus 5, guys. Remember that when we're solving a square root, you have two sides to that root. 5 times 5 is 25, but negative 5 times negative 5 is also 25. Does that make sense? So now I add 2. This is where a lot of people get messed up. Guys, realize this is a positive 5 plus the 2, comma, a negative 5 plus the 2. So my x will equal 7, comma, negative 3. Does that make sense to everybody? We got this? Okay, number 4. I did this on purpose. Don't stress out. Minus 20 to both sides. Y minus 5 squared equals negative 16. In a normal Algebra 1 class, nothing wrong with it. Algebra 1 is awesome. But if we were just taking Algebra 1, at this point, you'd have a problem. You have y minus 5 equals plus or minus the square root of negative 16. If you were in Algebra 1, you would say, oh, no solution. But luckily, we have graduated to Algebra 2. What does that mean right there? Thank you, my brothers. So this is y minus 5 equals plus or minus 4i. Add the 5 to both sides. Please pay attention to how you write this. This is y equals 5 plus or minus 4i. What does that mean? It means that it equals 5 plus 4i and 5 minus 4i. Seriously, does that make sense, my friends? Someone say no? Yeah, we got this? Pretty simple, right? That's because you guys are awesome. How about this one? Make the y 0. Again, I did this on purpose. So don't stress it. I did this on purpose. Subtract 81. Negative 81 equals x squared. Anyone who does not know will go, oh, sorry, no solution. We know better. X will be plus or minus 9i. Do you see now why I taught you complex numbers? Do you see why now I taught you radicals before I did this? Okay? Yes, sir, my brother. It does take out the negative. That's why it's 9i. The plus or minus here does not come from the I. The plus or minus comes from 9i or negative 9i. If you square them, you're going to get negative 81. You square that, you're going to get negative 81. The plus or minus comes from the root, not the negative. The negative gets done with the I. But this plus or minus comes from the fact that it's a square root. Does that make sense? You promise? Okay. Last but not least, I'm going to erase. Subtract 14 to both sides. X squared equals negative 12. Square root. X equals plus or minus. First of all, take out that negative. Remember, you got to have an I, right? So that's 4 times 3, so it's going to be plus or minus 2i square root of 3. Does that make crystal clear sense to everybody? Yes? Cool. Next. Completing the square. Okay, completing the square. Completing the square allows you to transform unfactorable trinomials into factorable perfect square trinomials. If they told you this, solve, and you had this, I'm just making something up, you factor that out, x plus 4, x plus 2, zero product property, x would equal negative 4 and negative 2, right? We know that backwards and forwards, correct? Okay. What happens when you can't factor them? You use what's called completing the square. How does it work? Super simple. You can make a perfect square trinomial as long as you have an x squared and a bx. All you have to do is add b over 2 squared, and you will make a perfect square trinomial. What am I talking about? If I have x squared plus bx, if I add a b over 2 squared, I will get x plus b over 2 squared. I will create a perfect trinomial. Let me explain how this works. Before we learn how to solve a quadratic equation by completing the square, let's practice the simple act of just completing the square. For example, 1. Identify the b. What's the b here? No? Negative 10. 2. Find b over 2 squared. What's b over 2? Guys? Negative 5 squared. Leave it like that. Do not make it 25. Why, Mr. Morrow? Because when you get to fractions, it's going to get really nasty if you don't do it the way I'm telling you. So my b over 2 is negative 5 squared, right? Add the value of b over 2 to complete the square. So I've got 10 squared minus 10x plus negative 5 squared. You guys with me? And last but not least, rewrite the square of a binomial. Now, let me show you what you're supposed to do, and then let me show you how my trick is the best. This technically becomes x squared minus 10x plus 25, which comes out to be x minus 5 squared. It's a perfect square. Now, a lot of people don't see that. So first of all, they're going to go like this. They're going to go like that. Okay, what times what is 25? We're going to have to get is negative 10. Oh, okay, negative 5. Then they're going to go x minus 5, and then they'll square it. You can do that. I don't suggest it. I suggest doing it the easy way. Once you have created your perfect square through completing the square, please factor it like this. Square root of the first is, now, square root of the second, square it, and you're done. So basically, the square root of this and the inside part of the last one, the inside part, the b over 2. You put them together, square it, you're done. And that's how you complete the square. We're going to do more questions. The negative 10, I already factored this. I'm doing a shortcut. Isn't this x squared minus 10x plus 25? What times what is 25, but when added together is negative 10. So doesn't this factor out to be x minus 5 squared? I'm factoring the trinomial. So that's what happened to the 10x. But that's going to take a long time, especially if you have fractions. So take the square root of the first and the inside part of the b over 2 squared, including the sign, and square it, and you're done. Does that make sense? Yes? Okay. Let's just complete the square. What's my b here? Not 6x. What's my b here? 6. What's b over 2 squared? 3 squared. How do I factor this? The square root of the first and the square root of the second. Squared. Done. Do you see that? Okay. For b, what's my b over 2 squared here? 4 squared. Very good. So, this is really simple. I want to factor it. So square root of the first and the inside part here, that's a positive. So plus 4 squared. Done. What's my b here for c? Negative 32. What's my b squared? B over 2 squared? Plus a negative 16 squared. How do I factor this? Square root of the first. The inside part of the b over 2 squared. Done. Do you see this? Promise. Last but not least, this is where they get funky. Okay? This is why I tell you, do not square it. What's my b here? What's my b over 2 here? Do not turn it into decimal. Leave it as a fraction. This will be negative 5 halves squared. Now, If you do it the way most books and teachers teach you, you'd have to factor this. How much fun do you think that's going to be? Okay? It's not going to be too much fun. However, Mr. Morrow taught you a better way. Square root of the first, the inside part, minus 5/2 squared. You're done. Do you see this, guys? Do you see how much more beneficial it is not to square it, but to follow my shortcut? You promise? Okay. Now, how to solve by completing the square. Now we're going to solve. We were just learning how to complete the square. Now we're going to solve by completing the square. Solve the equation 3x squared minus 12x plus 6 equals 0. Okay. First things first. Isolate the ax squared and bx and divide a to both sides. If you have an a that is other than 1, like you do here, first thing you want to do is divide by 3. So that's going to give me x squared minus 4x plus 2 equals 0. And now let's get the x squared and the x alone. So I've got x squared minus 4x equals negative 2. That's step 1. Does that make sense? I'm here for you guys. So far, so good? Promise? Okay. Now, step 2. Complete the square by adding b over 2 squared to both sides. Remember, whatever you add to one side must be added to the other. So, let's do it. I got x squared minus 4x plus, what's b over 2 in this case? What's b over 2 in this case? Negative 2 squared, which I have to add to the other side. On the other side, you can go ahead and simplify it to 4. You guys with me here? You sure? Step 3, factor the trinomial. Okay, guys, this is the part I just taught you and trained you for. Square root of the first, inside, minus 2 squared, equals, negative 2 plus 4 is 2. Step 4, find the square roots. Square root both sides. X minus 2 equals plus or minus square root of 2. Step 5, solve for x. Add 2 to both sides. So x equals 2 plus or minus square root of 2. It's a little lengthy in process, but it's pretty simple, isn't it? We're going to do some more examples now. Sir? Yes, whenever you have an actual equation and you have to solve it using this, you got to add the b over 2 squared to both sides, sir. That's absolutely correct, sir. Does that make sense? All right, let's do another one. Okay, whoa, what's going on here? Don't stress it. First, get the x's together, get all the other numbers on the other side. So I'm going to subtract 3 and I'm going to subtract x to both sides. So I'm going to get 2x squared minus x equals 6. Minus 2x squared. I did it right, I just said it wrong. This is 2x squared minus 2x equals 6. Does everyone see that? Yes? No, bro. I'm taking this x over there. Yes. And I'm taking this over here, though, because I want to get the x squared and the x alone. Thank you for caring, though. Thank you. Now, I have an a in front of the x squared, so divide it. So now I got x squared minus x equals 3. What's my b over 2 in this case? b is negative 1. What's my b over 2 in this case? So I'm going to have x squared minus x plus negative 1/2 squared equals 3 plus negative 1/2 squared. I have to add the b over 2 squared to both sides. Do you see this, guys? Are you sure? You sure? Okay. Now, let's finish over here so I have more space. Let's go ahead and factor this bad boy out. What does that factor to? X. Beautiful. Minus 1/2 squared. Beautiful, guys. That's going to equal 3 plus negative 1/2 squared is 1/4. This goes to 4. That goes to 12. So I've got x minus 1/2 squared equals 13/4. Square root both sides to cancel out the power of 2. So I got x minus 1/2 equals plus or minus square root of 13 over 2. Do you see that? Because the square root of 4 in the denominator comes out to be a 2, correct? Guys, you with me? Add the 1/2 to both sides, and you will have x equals 1/2 plus or minus square root of 13 over 2. Does that make sense? You give me your word. Because I'm going to have to erase it and do the next one. So talk to me, my brothers. Yeah, because I found the square root of 13 over 4, but the square root of 13 doesn't break down, but the square root of 4 does in the denominator, so it's square root of 13 over 2. Yes, sir. Yeah, I square rooted both sides to get rid of the power of 2. What do you mean, what do? I found the square root of 13 over 4. I got 13 over 4 because 3 plus 1/4, that goes to 4, that goes to 12. I added fractions. Okay? I'm going to do another one. So I'm going to erase this. I'm going to do another one. Let's look at number 2. First of all, you make that a 0. This is x squared plus 3x minus 6. Add the 6 to both sides. 6 equals x squared plus 3x plus, what's my b here? 3. So my b over 2 is 3/2 squared, which I add to both sides. Is everyone with me so far? Okay. So this is 9/4 plus 6 equals, I factor this out, which is the square root of the first and the inside, so plus 3/2 squared. 9/4 plus 6 over 1, the denominator is 4, that goes to 24, so that's 33/4 equals x plus 3/2 squared. Square root both sides to cancel out the power of 2. So I have x plus 3/2 equals plus or minus square root of 33 over 2. When I simplify that, subtract 3/2 to both sides, x equals negative 3/2 plus or minus square root of 33 over 2. Okay, I see some faces. Talk to me. I'm here for you. I don't want you to think you're alone here. I'm here for you. This is new. This is long. Talk to me. It should be easy, but talk to me. Talk to me. We're getting it? You guys are awesome. Okay, let's continue then. In this case, I do not have an a that is greater than 1, so I don't have to divide anything. I am going to get the x squared and the x alone, though. So I got x squared minus 4x equals 96. My b over 2 is going to be negative 2 here in this case. So I'm going to go minus 2 squared. which I have to add to both sides. What does this factor out to be? X minus 2, beautiful, squared, equals 100. Square root both sides. X minus 2 equals plus or minus 10. Add 2 to both sides. X equals 12 or negative 8. Does that make sense? Is anyone dying right now? Well, that's why we have a video. Okay. Next. First thing we're going to do here is add the 2 to both sides. So I've got 9x squared minus 12x equals 2. I have an a in front of the x squared, so I'm going to divide everything by that a. So I've got x squared minus 12 ninths divide 3, so that's minus 4 thirds. X equals 2 ninths. Please be careful here. The b in this case is 4 thirds. b over 2, remember, stay, change, flip, right? So that's going to be 2 thirds. 2 thirds squared, very good. So x squared minus 4 thirds x plus plus a negative 2 thirds squared. Good luck factoring that, guys, if you do it the long way. Good luck. So I got my 2 ninths plus negative 2 cubed squared, 2 over 3 squared rather, is 4 ninths. What does this factor out to be? X minus 2 thirds, beautiful, squared, equals 6 ninths. Square root both sides. X minus 2 thirds equals plus or minus square root of 6 over 3. Add 2 thirds to both sides. X equals 2 thirds plus or minus square root of 6 over 3. Does that make sense, guys? And sorry, this came out a little bit messy. That's square root of 6 over 3. Are you guys seeing this? Okay. Now, last thing. We're going to be applying the Pythagorean theorem. The Pythagorean theorem, I'm sure you learned in pre-algebra. It deals with square roots because it deals with a formula that happens to deal with right triangles and only right triangles. Right off the bat, guys, you know it's a right triangle if you have this little square symbol here. And the side that is largest, always, and the side that is opposite the 90 is called the hypotenuse. We'll get right to it. Okay, so the side across the 90 is always, 100% of the time, the C value. That's your hypotenuse. And then these guys are known as your legs. It doesn't matter who you call A or who you call B. As long what really matters, though, is the C. The C is the hypotenuse, and only the hypotenuse, always 100%. How does it work? Very simply. In a right triangle, one leg's, what? What? That makes no sense. In a right triangle, one leg's with length, I don't know. In a right triangle, how about it, which has, little typo there, legs with lengths 5 inches and 12 inches, find the length of the hypotenuse. Okay. So you know there's a hypotenuse, you got to create a right triangle. That's the hypotenuse right there. That's who you're solving for. That's my C. One of these legs is 5, one of them is 12. So, leg squared plus leg squared equals C, or hypotenuse squared. 25 plus 144 is 169, which equals c squared, square root both sides, plus or minus 13 equals c. However, you cannot have a negative side for a triangle, so c equals 13. Again, just knowing how to work with square roots. Okay? Now, I'm going to do this next one because it took me a long time to come up with and find the little graphics that I gave you. So we're going to do this. But we're going to use calculator to help us out. A lighthouse located in Maine stands 162 feet tall, with the observation deck located 158 feet above the ground. If a person were standing on the observation deck, he or she could see approximately 18 miles. Assuming the radius of Earth is 3,960, verify this claim. So the little dude is up here, okay? And from here to the bottom is not 162. It's 158 feet, right? They tell you that the radius of Earth, which is this guy right here, that's 3,960 miles. Okay? They say that he can look for 8 miles. This is what we're going to test. 18 miles. That's what we're going to test for. Okay? This here creates my 90-degree angle. So this is my hypotenuse. Now, if you pay attention to this, guys, the hypotenuse is also the radius plus 158 feet, right? So this is 3,960 plus the 158 feet. Yes. Not no. Yes, just wait. So, my hypotenuse is 3,960 miles plus 158 feet. How do I turn that into miles? 158 over 5,280. Because there are 5,280 feet in 1 mile. So that is my hypotenuse, which I square. That must equal 3,960, which is one of my legs, squared, plus 18 squared. If you plug that into your calculator, it has to be equal. If it is not equal, then the claim is wrong. If it is equal, then the claim is correct. So I'm going to cheat as well. I'm going to use my calculator. First thing I'm going to do to make my life easy is I'm going to say 158 divided by 5,280. I'm going to add that to 3,960, and then I'm going to square it. So that's going to equal this number right here. Okay? Now, 3,960 squared equals 156,81837 plus 18 squared. 18 squared equals 324. Add them together. 156,81837. No. Oh, wait, I did something wrong. This one here I did wrong. Hold on. So I got 3,960 plus parentheses 158 divided by 5,280. That equals, square it. Yeah, it's insignificant here. It's pretty much the same thing here, guys. Because I've got 158 divided by 5,280. So, plus, let's see, 3,960. Yeah, it's so insignificant. When I square it, it's rounding it off for me. That's why. So it's, yeah, 156, 81837. Yeah, it's not going to be the same. This is larger. So this cannot be 18. It has to be less than 18. Before you leave, you were saying, how did you get what?
Once again, Mr. Pino's triathlon member, please report to the mouse.
This was so insignificant that I really didn't increase or decrease the value. Okay? What's important here, guys, is that you understood that it was this side squared plus this side squared, equals this side squared plus that side squared. Have a great day. Thank you for your patience. Have a great one. Thank you.